Good afternoon, everybody. My name is Nantale Nsibirwa, and like Alex said, I'm from the University of KwaZulu-Natal. I'm part of the Center for Water Resources Research, and today I'm going to share with you my master's research. And my supervisors are Prof. Graham Jewett and also Mr. Mark Huran. So just basically to give you guys a presentation scope, I'm first going to give you the background to my research. I'll then move on to my aims and objectives. I'll then touch on a few highlights from my literature review, and then I'll move on to my research methodology, and I'll be able to give you some of my preliminary findings from my research, and then we'll discuss some of the limitations of the project. So basically, I just want to define diffuse pollution. And unlike point source pollution, which can be traced back to a specific pipe, diffuse pollutants are located all across our landscape, and they are carried with runoff into our streams. The specific diffuse pollutant I'm looking at are nutrients, and that's because they cause this problem observed here, and that's eutrophication. So excess nutrients from the landscape flow into the rivers and encourage algae to grow excessively. This is just a picture of Midmar Dam, and the stream on the left side of the slide is carrying with it pollutants, and as you can see, algae is starting to grow on the surface of the dam. So specifically, I'm looking at diffuse pollution within the uMngeni catchment, and that's the catchment that supplies water to the Pietermaritzburg and Durban areas. Recently, there's been a great push within the catchment to invest in ecological infrastructure, and this slide is meant to give you a context of my whole project, and it falls under the uMngeni Ecological Infrastructure Project, and the whole point is to invest in naturally functioning ecosystems such as wetlands, as you heard earlier today, and the river network itself in order to secure water for the growing populations within the catchment. So in that context of looking for where to invest in our ecological infrastructure, two questions come up, and this is where in the catchment is the diffuse pollution coming from? Where are our critical source areas? And secondly, people want to know how are these source areas connecting to the river network? So it's a question of connectivity in the landscape. So this leads me to the aim of my project, and that's to identify the critical source areas and transport pathways of nutrients within the uMngeni catchment. Specifically, I want to utilize a risk-based method for diffuse pollution assessment, and in the slides that follow, I'll explain why and what exactly that is. So just to go over my research objectives, I want to review and examine the various recent risk-based approaches, and then from there select one to be able to map the critical source areas and transport pathways of nutrients in the uMngeni catchment. From there, I want to develop a map to inform various stakeholders. And the bigger intention with all of this is that the information used here would be used by people who have to make decisions on where in the catchment to invest in ecological infrastructure. So moving on to my literature review, it focused on two things. Firstly, I looked at the conventional methods used to assess diffuse pollution potential. Then I went on to look at the more recent methods of assessment. So conventionally, what has been done within the catchment and around the world is people either conduct water quality modeling where they simulate a pollutant load, or they conduct routine monitoring. So they go out into the river networks, collect water samples, and take them back for lab analysis. There are a couple of problems with these methods, and firstly is that water quality modeling for simulating pollutant loads can be a result of over-parameterization, or can be subject, rather, to over-parameterization, and routine river monitoring can be a tedious process. And with both of these methods, we still don't get a picture of where in the catchment diffuse pollution is coming from, where the sources. So in terms of modeling, researchers are now looking at risk-based methods. And the main advantage of risk-based methods is that you get a map output, and this is a basic example of that. You get to see where in the catchment areas are at high risk of contributing to the observed problem within the stream. So as you can see in this simple map, areas in red are considered to be high diffuse pollution risk areas. Areas in green are relatively low risk. So reasons for using a risk-based method: firstly, it gives a spatial representation of diffuse pollution. Secondly, the map outputs are very practical, and you'll get to see that in the slides to come. And thirdly, the input data for such models is generally readily available. So this table is a simplified version that I put in my literature review, and it basically shows why I selected the model that I did. I just want you to focus on two things. Firstly, the criteria which I used to select a model to apply in the uMngeni catchment. I looked at the key outputs of the method. I looked at what spatial scale it's been applied, the data requirements, and then lastly, whether I was able to access the software and resources necessary. So second thing I want you to focus on is that the SIME-MAP modeling framework met all my requirements for modeling diffuse pollution in the uMngeni catchment. So just moving on to my research methodology. Like I said in the slide before, I had to select a risk-based method to apply in the catchment, and then I went on to acquire this data and process it to get it ready for the modeling. And then I actually conducted the modeling. Recently, I think 2 weeks ago, I was able to do some of the ground truth work and see whether what the model was showing is actually in the catchment. And then lastly, I'm going to create a digital map to inform stakeholders. So just on the model itself, it requires three main inputs, and firstly, we require a digital elevation model. So I was able to access one that was developed in the Department of Water Affairs. And secondly, it requires a land cover map, and for this exercise, I was able to get the Ezemvelo KZN Wildlife land cover map. I used the 2011 map. Third data layer required by the model is an indication of rainfall within the area. So with this, I was able to access a MAP, mean annual precipitation grid created by Lynch in 2004. I was able to access it through the center. So this slide is just to show you some of my preliminary results. Sorry, I'm just trying to press play on the video. Okay, I can't press play. Okay, there we go. So basically, what I'm aiming for with my outputs is that an individual or user can be able to zoom into an area. It will most likely be an aerial-based map so that they can compare modeled outputs with what's on the ground. I want the user to be able to switch on and off the various layers produced by the model. And yeah, I'm going to show you now some of the results for the uMngeni. The first layer created by the model is an indication of connectivity. So areas in red are said to be highly connected to the river network. Areas in yellow/orange are at low risk for connecting to the river network. So the next layer that the model creates is an indication of the critical source areas. And in this layer, areas in red and yellow/orange are considered to be at high risk for contributing to the diffuse pollution in streams. green areas are considered at very low risk to contribute to the problem. So I'm going to zoom into an area so you guys can see a bit better what it shows. So here it's saying that those agricultural fields are most probably causing the observed nutrient problem within the streams. And the final layer that the model creates is an indication of the transport pathways the nutrients take. And this takes the risk and it creates a pathway to the main channels. So I'm just going to zoom into another area to show you. So once again, these agricultural fields are said to be most probably what's causing the nutrient problem downstream, and then the model plots the route of the nutrients into the main channel. So just to move on to some of the limitations of SciMap, and SciMap is not meant to be a detailed water quality model. It's a simple function. It does not quantify pollutant loads, so it can't give you concentrations within the streams. And thirdly, it's that it can't create a time series of predictions. And it just creates a spatial representation of the problem. And also, lastly, is that the maps are a hypothesis. So that means that in actual fact, in real life, you can go out and you must check what is actually happening on the ground. The model just gives you an indication of where to look first in the catchment for the problem. When you get on the ground, you could find that there are land management practices in place that make an area that was considered high risk to be low risk. So just to conclude my presentation, is that diffuse pollution is a problem that's been affecting our ecological infrastructure. And in order to invest in ecological infrastructure and protect it, we need to know, secondly, we need to identify where the problem is coming from and how is it connecting to the river networks. Thirdly is that risk-based approaches can be applied within the uMngeni catchment. And fourthly, we need to be mindful of the limitations. And just to acknowledge my supervisors, my funding, and people who've provided me data and technical advice. Thank you.